Hi everyone, good morning. I hope you are able
Good
to hear me.
morning. Good
Hi
morning, sir.
Bhaskar, morning.
Very good morning. Yeah, so in the last session, we have seen how we can replicate the data with redundancy and what are the different types of pricing tiers we're having. So pricing will be decided based on the storage, how much time that you're going to store, and then how frequently you're going to access the data. Based on that, the cost will be decided. All those things will be handled by someone else. We are not going to be part of it. And next thing is, as a data engineer, we should know about the data and its formats. And before starting it, I think I talked about how we can access the storage from outside ADLS Gen 2. So that I'm going to show you. Then we'll talk about we'll start talking about data and its formats. So we created a storage account. Let me log into the portal. Let's go to the storage accounts. Bhaskar ADLS Gen 2. Let's open it. And there is a security. Okay, basically they are going to give a with Microsoft Entra ID. For Entra ID only, they are going to give a access. Okay, so for practicing purpose, I'm just taking a access keys. So access keys are not the better practice to give a access to you. I mean, at the time of working. So with access control, they're going to give a access. Like when you go and work in any company, you will be having your official mail ID, right? What I can say, Active Directory or so user will be there. So that user they're going to add in this place. So now Microsoft is calling that as a Microsoft Entra ID. Microsoft Entra ID. Okay, so they're going to give you access to that. So you don't need to worry about it. You can directly log in. But here I'm just going to use in a different way. With the key, I'm going to take it. So various options are there. You can log in from outside with this key or with the connection string. Also, you can log in. Let me take a connection string for practicing. And you have to install, as I said in yesterday's session, you have to install Azure Storage Explorer. Azure Storage Explorer, you have to install. Let's open it. Everyone should install this one. At least if you habituated sometime, then it will be helpful for you. Now I don't have any accounts here. So I wanted to add it. Let's right click on it. Connect to Azure. Hit on connect to Azure. And then 1 minute, let me try it again. Let's connect to Azure. We have a various options here. Depends on the security that they have. I mean, depends on the access that they have provided. Based on it, we need to choose it. Mostly you're going to use the subscription or you're going to use the storage account level. So I'm just taking a storage account and I have a 3 different options to connect it. I'm taking a just connection string. Let's go to next. And provide the connection string here. Whatever I copied from here, I just pasted in this place. And storage account name also is captured automatically. This is just display name. Let's say next and hit on connect. So once it is connected, you can see here blob containers, file shares, queues, tables. Expand the blob containers and see there is a data files because we already created a data files container. If you want to create a container here, from here you can also create a container. So I'm just saying landing is my container name. You can see here. So this is very important to copy a file from one container to another container. So I have a folder here. I can copy this, copy it and paste it here in the landing. Paste it. You can see the input folder in the landing. So this the similar kind of work you are going to do it in the real time. Okay, so you cannot do this activity from the portal. From the portal, it's not having feasibility to copy and paste it. From here, we have a copy and paste it. So in the landing previously, I don't have anything. Now you have a data also. Folder itself, I copied. So whenever you're going to do some testing, you're going to take the data from the production to dev environment by using this Azure Storage Explorer. In that case, it is useful. Okay, so let's move on to talk about data and its formats. So what kind of data you're going to store in the ADLS, or what kind of data you're going to handle as a data engineer? We have three varieties of the data. Most of you may be aware of it. That is structured data we are having. Structured data. So structured data is something like this. You are going to have a fixed columns. Fixed columns you are going to have, and at least if you go for RDBMS tools, RDBMS tools like databases, the columns also fixed with the data types. I mean, data types are bounded to your columns. Okay, so structured data means fixed columns will be there in simple word. So it is going to have a tabular data representing by rows and columns you're having, fixed schema, and SQL can be used to interact with the data if you have a data in a SQL server. And each row is going to have a same number of columns. Number of columns are not going to change when you go for structured data. So all relational databases are going to maintain structured data. Like I've given here SQL Server, Azure SQL Server, MySQL, PostgreSQL. In the same way, the same structured data also will be there with the CSV files also, comma separator files. Okay, so .csv files and Excel files also is going to have a structured data. Data types are not bounded, but still you're going to have a fixed number of columns. So you can feel that is a structured data. Okay, so on text with delimiter, text data with delimiter also will be treated as a structured data only. So example snip I have given, and most of you are aware of it. Okay, so another set of data is semi-structured data. Okay, another set of data I'm just taking semi-structured data. So semi-structured data is not going to have a fixed schema. How can we maintain the semi-structured data in the ADLS? ADLS, they have given, apart from the blob storage, they have given table storage also. Table also can create. Yesterday we have seen how we can create it. So we don't need to have a same number of columns. You can change the number of columns. But basically, as a data engineer, we are not going to take the data from here, but surely we are going to take the data from the JSON files. They will ask you in the interview also. So what kind of files or what kind of formats that you have handled as part of your experience? You can say CSV files. You can say JSON files. And you can say Parquet files. We are going to see what file formats we are having. We are going to come across it. So each record has number of properties, variable number of properties. So here, if you observe in this particular place, I'm having 3 columns here. But here in this record, I'm having 4 columns. So number of columns are not fixed. If number of columns are not fixed, then we can say it is a semi-structured data. It is a light-weighted file. So why people are using this JSON files is they are light-weighted files. And later Parquet came into picture. It's a different story. And this is important for many places. Where exactly we are going to come across this JSON files is because if your data source is a JSON, that is fine. You are going to read the data from there. In our case, we can have a config details in the JSON format. It's easy to handle it if you have a config in the JSON files. And no fixed schema, flexible structure, and NoSQL kind of data. Basically, all NoSQL databases follows JSON kind of storage only. And you are going to have a key value pair. An example is JSON file or XML file. And I have given here example MongoDB, Neo4j, Redis. And from Azure, we have a table store and Cosmos DB. So all these people are going to store in the form of semi-structured data. So we are going to handle, as a data engineer, we are going to see how we can handle the semi-structured data. The next is unstructured data. So if you don't have a structure, then you can say it is a unstructured data. No predefined structure for the data. Like an example is text data, plain text data. Like your emails, your mails are unstructured data, right? And your feedback, if you give any feedback, the feedback is going to be unstructured. Your messages is unstructured. Okay, so all I just listed images, text files without schema, sensor data, social media data, emails, video files, audio files, log files. All this will be treated as a unstructured data. So we are going to see how we can handle a text data, a text file without schema. And if you have a text file without schema, a plain text, how you're going to handle it, that we are going to see. And then I'm just going to talk about file formats also. What are the different types of file formats we're having? So this is also as part of your DP900. So delimited text file, most of you are aware of it. A comma separator or tab separator or space separator. There will be some separator will be there. Like in a employee file, employee.txt file, employee number, comma, employee name, comma, job, something like that. You can have the data. So that kind of data, we can call it as a delimited text files. Okay, so especially CSV files, you are going to use it, .csv. From where we are going to have is like when the data, when sometimes they may not give a direct access to the database. Okay, so in one of my previous project, we don't have a direct access to access the Oracle database. So what they used to do is they used to keep the files on every day, end of the day. So in the form of CSV and SFTP. So from SFTP, we used to bring the data into the landing. We are going to have a landing and bronze, silver, and gold. We'll see about them, how exactly the naming standard will be there as part of the project. But generally, sometimes they are going to keep the data in the SFTP. From SFTP, we have to take it. So when they keep the data in the SFTP, 99% is they're going to keep the CSV files. In my case, it happened. In your case, maybe some different extension also they may give it. But surely they don't give a Excel, because Excel will be having multiple sheets and Excel will be having a limitation in the number of records. In CSV, we can have a more number of records and single sheet will be there. And then we have a JSON files, as I said. So this is also very important. We are going to see how we can do it. And lightweight file, as I said, and human readable data format. You can easily understand by reading that, you can understand what it is. Okay, so just go through them. And structured data between servers and web applications, you can move it. And simplicity, readability, and broad support across the platform. So this JSON file will be supported for any kind of system. That means ADF can handle and your ADB also can handle it. Okay, so it will be useful in many places. Even Python also can handle it. So many applications or many systems supports your JSON files as they are lightweighted when they're transferring the data from one place to other place, then there is a chances to have a JSON files. And then XML also, we are going to have it. Okay, so this is also is going to be readable. Before JSON, there is a XML only. Okay, so if you ask me, is XML or JSON, I personally support for JSON. Okay, so similar kind of approach you can have even in the XML also. And then we have a binary large object, like binary files. You're going to have a ones and zeros. All files are ultimately stored in a binary data, and sometimes unstructured data will be there in the binary format. You can have it, especially if you have a data in the binary format. If you have a data in the binary format, that data you can read by using a binary connection. A format, when you go for format, you can find the file format is binary format in the data factory. I'll show you how exactly it is going to be there. That binary data you have to convert into other formats. Different formats you can convert it. It's all depends on you. So that is about this blob files. And here, this is important, Avro. Basically, the people who are having some experience with Hadoop, or if you're trained with the Hadoop, you may be heard about this Avro and ORC. In my experience, I did not come across anywhere because I did not work with the Hadoop. But these files are Avro is a row-based format it is, which is created by Apache, and each record contains a row header that describes the structure of the data in the record. Okay, so I'll show you how we can read the data from Avro file by using Azure Data Factory. Okay, so how we can read it, we'll see. This is one of the format to handle the data. So whenever you are going to deal with the file system, definitely you may have a data in the Avro also. If they use the Hadoop, then there is a chances to have it. If you have, then how you can read the data from Avro, we are going to see. With the Databricks, I'm going to show you, and with ADF also, we are going to see how we can do it. But I feel ORC is much more better than this Avro because it was optimized row columnar storage it is. So the data is going to be stored in the column wise, not in the row wise. If you store the data in the row wise, it kills the performance. Performance will be low. When you store the data in the column wise, then performance will be faster. So it is going to be faster, more 50% will be faster, if I'm correct, or more than that also. And storage, like we're going to reduce, especially, I'm not sure about this ORC, but I'm sure about the Parquet. So Parquet is going to store in the same way, like row columnar storage, sorry, columnar storage it is. This is optimized row columnar it is, but this data is going to store, of course, even ORC also is going to store in the columnar storage approach. So that improves the performance and reduces the size of the data also. Let's say, for example, you're having a CSV file, which is having, just imagine, 1 GB file is there. Okay, so you may have a multiple CSV files. I'm just taking a reference. When you upload this, when you convert this CSV file into Parquet file format, then 75% of the size is going to be reduced. Your actual size is 1 GB. Once you convert into Parquet, then it is going to get 0.25 GB. So how much size is reduced? 75%. 75 to 80% it is going to reduce when you go for Parquet files. So this is important for you. 100% is, as a data engineer, you are going to use, especially when you use the Databricks, I'm sure you're going to use Apache Parquet. It's an open file format it is. Okay, so since it is an open file format, most of the people are using Parquet format only. So as I said, when you use this one, it is going to reduce the size of the data. And the key features are there here. So the features is you don't need to specify the data types. If you read the data from the CSV, data types are not going to be assigned automatically. Okay, so most of the data types will be treated as a text data types, especially in the data factory. When you read the data from the CSV file with the data factory, the columns will be treated as a text data type. And if you use the data flow, there is a data flow concept. By using data flow, you can change these data types mostly, but someone is going to identify the data types by reading the data. So some person is there here. So what person that is, will see that. So some person is going to read the data, some sample data. Based on the sample data, it assigns the data types in the data factory. But if you go with the Parquet file, you don't need to do that. You don't need to do that. The schema also is going to be there as part of the file, but that is not going to be visible to you. That is not going to be shown. Okay, so automatically the schema evaluation will be taken care by file itself. So data is going to take a columnar storage. So it improves the performance and efficient compression. Snappy is going to be there. GZIP is there. Mostly Snappy is going to be taken by default when you go for efficient because it has to shrink the data. And faster query performance. Why, if you go for Microsoft Fabric or Lakehouse, they're using this underlying storage format is going to be Parquet format only. So cross-platform compatibility and efficient IO operations, all are going to be supported when you go for the Parquet. So this is very, very important. There is a chances to ask in the interview also. So what formats you have used? Just say blindly Parquet format. If you say I use CSV file, that is the starting point. SFTP, very starting of your data engineering. I mean to say not your experience, your work. So data, if they're not giving a direct access on the databases, they may keep the data in the SFTP location as a CSV format. That place you are going to have a CSV. Right from the landing, you are going to have a Parquet file format only. We are going to talk about the medallion architecture. So this medallion is always, we are always going to have a Apache Parquet file format. So in one of my company, we used even JSON files also, but we have not followed medallion architecture. In that particular place, I created a notebooks for only reporting point of view. So that means the reporting team is required data cleansing. So that data cleansing we did by having the data in the form of JSON. So in my experience, I came across the JSON and I came across the Parquet in the database. No CSV. Okay, because that data will be stored in the row wise. So if you store the data in the row wise, then the performance will be less. I have given a comparisons here and features. What is the feature and Parquet file? You can see Parquet and CSV and JSON. Okay, so I did not come across ORC Avro in my entire experience. So the people who are having some experience with the Hadoop, they may come across it. But new generation projects and all is using the Parquet only. So I just kept only Parquet. So storage type here is columnar storage. Data is going to store in the column wise, not in the row wise. And if you go for CSV, that is a row-based storage, and this is a semi-structured storage. And compression is high. Snap is there. And even if you go for copy data activity, we're going to see as part of the your data factory, when you're loading the data into the Parquet file format, automatically it is going to take a snappy compression type. And CSV is low because it is a text-based storage. And this is a medium, you can have a gzip. And query speed is very faster here. Fast query performance. Query means because if you wanted to process the data, you need to read faster. You need to process faster. So reading also faster and processing also is faster because As I said, when you have a CSV files with 1 GB, and let me give in a different way. So let's say, for example, you're having employee.csv file. Okay, employee.csv file you're having. So this file size is 1 GB. If you convert this file into Parquet file format, if you convert this file into Parquet employee.parquet, then it is going to reduce the size up to 75%. It is going to reduce it. Now 1 GB becomes 0.25 GB. Okay, so your original storage is 1 GB. Once you converted into Parquet, you're having 0.25 GB. If you store this 0.25 GB in the ADLS, for only 0.25 GB only you're going to pay. You're not going to pay for entire 1 GB. You're not going to pay for entire 1 GB. This is there in the, when you have a CSV file, I'm sure it is going to be there in a SFTP. That file will be there in a SFTP, not in your location, not in your ADLS. So ADLS, you're going to keep as a Parquet file in the landing. The file is landed as a Parquet file format, not as a CSV file. Now in the cloud, you're paying for only 0.25 GB only. The cost will be different, right? When you store for 1 GB, you have to pay for 1 GB. But if you store 0.25 GB, then you're going to pay for 0.25 GB. Your original data size is 1 GB. Once it is converted, data remains same. There will be no impact on the data. The size is reduced because the columnar storage, and it is having a snappy compression. And you have this one, and you are using a ADF to process it. Just imagine you are using ADF to process it. If I use the same thing to process with ADF, then what happens? You have to process 1 GB data. For 1 GB, you just imagine it is taking 10 minutes. 10 minutes it is taking to process the data. Just imagine. But if you process this 0.25, then 3 times it is going to reduce, right? If you go here. So that means 2.5 minutes is going to take it to finish if you have a data here. When it is taking 10 minutes here, it is going to take 2.5 minutes. An example I'm taking. So that means, is time reduced or not? Time is reduced.
Bhaskar, I have one question.
Yeah.
Suppose for 1 GB, the data volume might be same whatever we have in the Parquet. In the CSV, whatever we have in CSV, the data volume would be same in the Parquet also.
No, never. Size will never same.
No, size I am not talking about, data volume.
Data volume, no, that's what, when I say data volume, that is the size only.
Suppose in the CSV we have around 1 million records.
Yeah. Quantity same. Here I have a 1 million records. The same 1 million here also.
Yeah. So how come the processing time improves when we have the same data volume like 1 million?
Let me say, this data is going to store in a row wise.
Okay.
Row format it is. Even databases also stores in the row. Okay, so if I wanted to take any specific data, you have to read all the rows. But when it comes to here, it's not like that. So in a column wise, it is going to store. So one is storage, another is compression. Here we have a compression. You're compressing the data. So size is reduced. When it is reading, it will uncompress internally automatically. You don't need to worry about it. We don't need to write any code for that. Okay, so size of the file will be reduced, and since the storage is a columnar storage, the performance is faster. Okay, so as per the Apache Spark, I'm saying it is going to take up to 75% is going to be reduced. So when you process this 0.25 GB of the data, your number of millions are same to same. There is no change in the quantity of the data, but size of the data is going to be reduced. So just imagine if you don't zip the file before transferring from one place to other place, the original size of the folder different. Once you zip it, then the file size will be different. You have seen many places, right? Like we used a zip softwares to zip the folders. The same way here also, you're compressing the data with snapping. So these are all inbuilt features, inbuilt of your Apache Parquet. Now, even if you do the same thing with ADB also, that's the same thing. This is much more faster than this even ADF. When you compare with ADF, ADB is very faster because the process is going to be happen in the RAM. Of course, here also it is going to be RAM if it is a data flow. And Microsoft Fabric also is there. Microsoft Fabric by default they're going to keep in a Parquet files. When the moment to keep the data there, that is going to be treated as a Parquet. Okay, so we are going to see that. But in general, I'm saying why Parquet is important is because of this. The performance will be faster. Definitely, you are going to have a filter conditions. Like there is a Delta Lake. We are going to talk about it. Delta Lake or Lake House, the same thing that we are going to call as a Lake House in the Microsoft Fabric. In the Databricks, we are calling it as a Delta Lake. So both are same. So Delta Lake and Lakehouse always going to have a data in the form of Parquet only, not other formats. So 100% is everyone is going to use the Parquet file formats. So because of that reason, it is very, very important. The storage cost will be reduced and processing time will be reduced. Clear?
Yes, Bhaskar, there are other compression methods also you mentioned.
Yeah, we have other
LZ.
other compression. Even this one also you can use it while taking the data, while writing the data into the target. But
So
mostly Snappy will be used.
is it up to us which compression method we need to use?
Yeah, of course, it is up to us, and recommended is a Snappy.
Okay.
Now let's talk about we have seen how we are having a file formats to deal with the data. Then what about databases? Okay, so Microsoft is having a relational databases and non-relational databases also. So relational databases is like SQL Server is a relational database, or Azure SQL Server also is a relational database. Azure Data Warehouse also is a relational database. A non-relational databases we have from the Microsoft, that is Cosmos, and table storage in the ADLS Gen 2. So all relational databases are going to store the structured data, and each with unique primary key. You may have a primary keys and foreign keys. Many things you are going to have. If you see this diagram, there is a fact sales table, which is having a dim channel, a dim date, dim product. This is a dimensional modeling. We have a dimensional modeling, and we have a even there is ER modeling also, entity relationship modeling for business systems we are going to have. And this is for data warehouses. People used to go for dimensional modeling. As part of our medallion architecture, there is a goal layer. The goal layer is going to have a dimensional modeling kind of approach. Only the difference between this data warehouse and goal layer, when you compare, there will be no relationship and there will be no primary key and foreign key kind of things, but we are going to follow the rules. I wanted to maintain a primary key means that will not allow duplicates. So that rule you have to follow in the gold. So that when you give this data to the reporting team can create a relationship in their tools. When they have a Microsoft Power BI, in Power BI, they can take the data into the Power BI. In Power BI, they're going to make a relationship like this to slice the data. But we have to give a dimension tables to them, and we have to give a fact tables to them. The similar kind of approach we are going to follow, but we are not going to make a relationship because there is no feasibility to make a relationship. And non-relational databases are going to have a varieties of options we're having to store the data. Okay, so non-relational databases like Cosmos DB, Cassandra database, these are all non-relational databases. Okay, so different way of storage we are having. This is a table storage. If you we have come across as part of our what I can say as part of our table storage. But way of doing it, that is completely UI. We have done with the UI, but we can also have without UI with key and values we can have it. So here I'm just specifying this is a dictionary basically. So key value pair we are going to have it. So what is a dictionary? We'll talk as part of the Python so that you can understand. So that is a key value based storage it is. You can have a name. So number of columns are different here and number of columns are different here. You can have as many number of columns as you want. And column family also is going to be treated. Okay, so this is about the storage, how exactly they're going to store the data. And this is a Microsoft document database is going to have the similar kind of approach to store the data. This is an internal mechanism how they're going to handle it. But when it comes to the data, when it comes to the Databricks, we are going to have a data like this. We'll see how the JSON files is going to have a key value format, and we'll see how we can handle it. Now, how we are going to process the data. Okay, so here I'm just taking at higher level, guys. But basically, when we start from the Monday, we are going to start talking about how we are going to process the data. How exactly we are going to process the data, we are going to see. And tomorrow, I'm going to talk about how we can set up the SQL Server in our Azure platform. So in Azure platform, how we can set up the Azure SQL Server that we are going to see. Okay, so little more details, I'm going to take you through that. So here, how we can process the data if you wanted to process it. So analytical data processing, you can have a client application. That means you can take the data from the client systems. When I say client applications, okay, so if you take Amazon, Amazon is having their application to run their business. Or if I take a ICICI, they have their own application to run their business. In the similar way, we are going to have a various applications to run their business. All these business applications are going to deal with the system called OLTP system. So in the interview, they may ask what is the OLTP system and why you are going to use the OLTP system, or can you explain the differences between OLTP system and OLAP system? They may ask. Okay, so you can give a few differences I have given in the next slide. You can go through them. But basically, at higher level, I wanted to say OLTP system is specifically designed for business. So business applications are going to deal with this system. Okay, so the design of this OLTP system is ER modeling, entity relationship modeling. They used to maintain the normalization here. So we are not going to have a duplicated data as part of this OLTP system. So different types of normalizations are there. We are not supposed to know about it because we are not going to be part of database developers or database administrators. We are not going to be part of it. So we don't need to know about it. Our part is completely different. Okay. So in order to use these OLTP systems, our OLTP systems can be used your SQL Server databases or SQL servers, Oracle, DB2, MySQL, all these other SQL databases can be used as a OLTP system. But most of the people are going to use the Oracle for their businesses to interact their business applications. In my entire experience, most of the times I used, but more 8 years I work for Microsoft. In that particular place, they used only their system, that is SQL Server, because they don't use other systems. So sometimes they may use, I'm not sure, but I did not come across it. So that is a OLTP system. That means your business applications are going to feed the data into OLTP system. How data is getting processed, I'm saying it. When you order a product in Amazon with Amazon app, they're going to store the data in their OLTP system. Your transaction details will be stored. Your order details will be stored. So once you have a data, then you need to process it. Why Amazon is required to process the data is because they need to understand the business. If they wanted to expand the business or if they wanted to grow in the business, then definitely they have to know what is happening in the business. So because of that reason, they require information. So a reporting team will provide the information to them. But who will give the data to the reporting team? Data engineers are responsible for that. Data engineers are responsible to give the data to the reporting team. If you are not there, then reporting team cannot handle this. Reporting team cannot do that. Reporting team cannot take the data directly from the OLTP system. Reporting team cannot handle the historical data. Reporting team cannot handle bugs in the data. It's highly impossible. Once you save the data, once you clean the data, then you can give the cleaned data to the reporting team. Then on top of it, they will get the insights for the reporting. They will get the insights for the business users. And the data will be stored into the OLAP systems. Analysis services will be used, like to move the data from here to here, we are going to use the ETL services. Previously, we were treated as a ETL services. From the OLAP systems, your reporting teams will take data into presentation point of view. Now, how we can process the data from our side? We'll say, I guess I have a slide for that also. Yeah, so for continuation of that, I'm just giving how exactly the data is getting processed. I'm just trying to explain. So when I say data sources, it doesn't mean that it is a OLTP system. Okay. From OLTP, they may keep the data in SFTP also. Your data source may be SFTP. So for that reason, I have taken a different icons here to present. These are all the data sources I wanted to say. So in order to give the data to the reporting team, we need to extract, transform, and load the data by using ETL processing. So this was the approach that we used to do it in previously. I mean to say before data engineering, this was the approach. Later we got ELT, extraction, loading, and transformation. We'll talk about it. So once you extracted, transformed, and then we are going to load the data into data warehouse. That was the approach that we used to do it. From the data warehouse, they will be having a cube or model. So tabular model will be there. Even I have experience on all these technologies. My actual career was started with the MSBI, with full stack of MSBI, SSIS, and SSAS. That time we created a cubes prior 2012, and even prior 2016 also we used all the tabular model, all the cubes was converted into tabular models. And then I have experience with even SSRS also. So 10 years ago, I worked with SSRS with pure development. Even now, I'm very perfect in SSRS. Of course, AS and IS also. Okay, so then once the data is there in the cube or in the OLAP, these two systems we can treat as a OLAP systems. OLAP means online analytical processing system. This system is designed for reporting point of view. For report users, it is designed. So visualizations can be used, and then that reports will be given to the business users. Okay, so this is how it is going to be processed. At higher level, I'm saying, we are going to see everything practically. I've given a differences here because in the interview or in the certification, they're going to ask differences between OLTP and OLAP system. As I said, it is a OLTP means online transactional processing system. OLAP is online analytical processing system. Analytical means for reporting point of view or reporting purpose. So this is for business users. Business users are going to access. When they're accessing the report means the report will take the data from the system. That means this will be accessed by the business users. But this is not by the business user, this is by the business customers. So customers we can say. Okay, so this Amazon app is required to use by us, not by the business, right? If they're doing a transaction, they may go for it, but basically they don't use it. Okay, so OLTP system used for business point of view. To run the business, we are going to use it. And simple query we are going to have, and here we are going to have a data warehousing because it is going to have a complex query. The purpose of this is for data warehousing. So complex query and simple query we are having, and more number of joins are required because they are going to have a too many tables having a joins, too many joins, because they wanted to maintain normalization. To maintain the normalization, they need to have a too many tables. So if they don't maintain the normalization, then application will not interact fastly. So faster interaction is not going to be happen. Because of that reason, they're going to have a normalization in the OLTP systems. So this is not our job. We are not going to be part of normalization. We are not going to be part of designing this data warehouse or designing this OLTP system. And access to recent data will be available as the business application is dealing with that. And database modifications will be happen. That means data modification. And usually this is going to be single database. And to run the business, we are going to use this. And this OLAP will be used for data warehousing point of view, and data will be collected from the multiple data sources. You may have a data in different data sources. You can collect and integrate all together as a single database. That is what it is saying. It is a denormalized data. So duplicated data is going to be there. Just imagine you are maintaining customer details. So if customer changes the location, definitely the location is going to be changed from one place to other place. Everyone is going to do, or everyone is going to be experienced. Even I work for multiple locations. So if you wanted to have all the locations from the beginning of my life, then definitely I need to have a history. So history means duplicated data. So duplicated data is going to be there only if you have a normalized design. Denormalized design if you have, then you can maintain the duplicated data. So you're going to have a complex query means like what we can say. Complex query means you're going to write a joins only. And long running jobs, you're going to use it here because it is an analytical purpose. You're going to use it. Used for data analysis, historical data, and Azure Synapse Analytics. Like Azure Synapse Analytics is going to have the petabytes of the data as part of the data warehouse. And dimensional modeling, you're going to have it here. So OLAP features are used in all these places. Even if you go for Delta Lake also, you're going to have a OLAP features only. Okay, so historical data you're going to have, massive volume of data you're going to have. Only only business users are going to access this, not every customer. Okay, so only for business point of view, if you're part of the business, then they're going to access the data from the OLAP system. So this is also one of the important topic.
Sir, one doubt, sir.
Yeah.
In Azure Synapse Analytics it is also a database only.
Yes, data warehouse. Azure Synapse Analytics is a umbrella. Under that umbrella, there is a Azure data warehouse.
Okay, sir.
Then I'm just giving a differences here between data warehouse and OLAP. Oh, sorry, there is a naming stand. I think it is a data lake. I'm sorry for that. Okay, so this is not a OLAP. This is a Delta Lake. Sorry, data lake. Okay, so data warehouse. What is the difference between data warehouse and data lake is because data warehouse is having some limitations. Okay, so if you want to store unstructured data or semi-structured data that you cannot store in the data warehouse. So decade ago is the similar thing, but now some databases are supporting to store even semi-structured data. Okay, so I just wanted to say the differences between data warehouse and data lake. It can capture and retain only structured data. This particular system will be having only structured data. Okay, so the data warehouse is always going to have a rows and columns. Like if you, as it is a table, then we are going to have a data in the form of rows and columns. All the data in this particular warehouse is going to be transformed and cleansed data, and which is ready for the business, which is ready for analysis. Okay, so typically schema is defined before data is stored in the data warehouse. So before storing the data, you have to specify the schema because schema is bounded to the table. Okay, so and data warehouse is ideal for business analysts. Basically, this is for business analysis only. We are going to use it. And the storage cost is very high. When you use the data warehouse, even if you go for Azure data warehouse, why people are not much using or why this signups is failed is because of this. The cost is more. Because of that reason, Microsoft is coming with the Fabric. Because in Fabric, they're using a lakehouse architecture. That means Delta Lake. So Delta Lake architecture they're using. Because of that reason, the cost will be less. Okay, so storage cost is very high and query result is time consuming. The performance will be less. And data warehouse is structured by design, which makes it difficult to access and manipulate. So in order to manipulate the data also is going to be a time-taking process. So there are many limitations out there. So I mean to say decade ago, it was fine. Before Hadoop came into picture, data warehouse is fine. Once the big data was introduced, then data warehouse is not capable enough to store massive volume of data. Then this data lake came into picture. So data lake can store structured data, semi-structured data, and unstructured data in the raw format also can store it. It's like a bucket, you can just dump it. You can just dump the data. And it takes all types of the data. You can take the numbers, text, any kind of data type can be taken here as it is taking all three different varieties of the data. So schema is defined after the data is stored. So basically schema is required on read, not on write. But here schema is required to write the data, and here schema is required to read the data. And a data lake is ideal for data engineers, data analysts, and data scientists. So this ADLS is a data lake only, right? So ADLS will be used by data engineers, ADLS will be used by data analysts and data scientists also. The storage cost is low when you compare to the data warehouse. It's very low. And data can be changed, updated quickly. So how it is going to be possible? I have a conflict in this statement. Okay, so if it is a Delta Lake, it is possible to do update. If it is just data lake, it's not going to be possible to do it as per my knowledge. So this is basically, I think it is not a Delta Lake. It is it is not a data lake. It may be Delta Lake. I'll cross verify. I'll rename it. Then what are the roles for data engineers or data related roles? What roles are there which is data related? If you are working as a data analyst, then you can work as a data engineer. Whoever is going to deal with the data, you can work any of these roles. Okay, so I started my career with, as I said, ETL developer. As a ETL developer, I started my career. So later I went for data analyst also. So as part of the data analyst, I used extensively with analysis services and Power BI. I'm having enough experience with Power BI and analysis services with Microsoft. And there itself, I started working with the ADF. Because I was the individual developer for entire project. So I have got an opportunity to touch many of the services. So data engineers is one of the role. Data engineers is one of the role to deal with the data. Okay, so they build and maintain data pipelines. We are going to create a pipelines. As a data engineers, your roles is to create a pipelines and ETL process, entire process, end to end, orchestration we used to call orchestration. So how we can do the orchestration with ADF we are going to see, and with ADB also we are going to see how we can do the orchestration. And data infrastructure for efficient data storage and data processing tools like Spark, SQL, and cloud platforms are the responsible. So data engineers means it's not only Azure data engineers, AWS data engineers are there, Hadoop data engineers are there. Whoever is going to deal with the data now will be treated as a data engineers. And data scientists also is going to deal with the data. They're going to take the data, especially from silver layer. Now, from gold layer, reporting team will take. From silver layer, this data scientist will take the data. So for data scientists, we are responsible to give the data, and for reporting team also, we are responsible to give the data. This is not a data scientist. This is a data analyst. So data analyst, data scientist, and data engineers are the roles of which is related to data. Okay, so relational databases, I'm going to talk about it. Okay, so we'll do one thing. I'll stop it here. So tomorrow I'm going to start talking about relational databases in Azure. That is what I told you, right? How we can use the SQL Server in the Azure. What are the different platforms you're having? So theoretically, you can go through them. Okay, but practical, I'm going to show you how we can set up this Azure SQL Server and how we can access with SQL Server Management Studio with SSMS, that we are going to see practically, so that when we start working with Azure Data Factory from Monday, you can easily understand how we can set up the resources. Okay. Any question, guys? If you have any question, you can ask me.
Azure Analytical Services, do you teach us?
No,
This
that's
is
not part of us.
Oh, okay.
Data scientist is not part of us. Data analyst is not part of us. We are going to purely data engineering. Okay, but in the Fabric, I'm going to touch. I'll just give you some idea, like if you are already having some Power BI experience. So if I say here we can create a model, then you can understand, okay, this is the place where we can create a model instead of creating a model with the Power BI. So that kind of knowledge there I'll give, but we are not going to discuss extensively. Like DAX, we are not going to discuss, and modeling we are not going to discuss. I'll just give an approach how you can do it in a Fabric.
This is not our role.
That is not our role. Basically, data engineers does not do the reporting.
Oh,
So data engineers only will give the query to for reporting team, sir.
Yes, yes. We are going to give the data to them and to reporting, data scientists also.
No, sir. Like for reporting team, we only should write the query and give
No.
them.
Why we need to write a query?
Okay, sir.
We don't, if that is the case, then what they're going to do? So
Okay.
reporting team will take care about it. Basically, they can, they do writing a code also, they do directly without writing code also, they can extract the data. But I'll show you how reporting, Power BI, how Power BI connects to the Delta Lake. I'm going to show you, so that if some report developer asking some questions, you can suggest them how you can connect to our systems if they are not aware of it. Okay, so that knowledge I'll give.
Okay, sir.
Okay, then we'll see you on tomorrow. Thank you for joining.
Thank you, sir.
thank you, sir.